Now, what happens when two continental plates collide with each other, or two land masses collide with each other? That's a key term called folding. Unlike subduction, which is ocean plate colliding with ocean plate, or ocean plate colliding with continental plate, here we have two continental plates, or two land masses colliding with each other, producing folding. This term also relates to another key term, orogenesis, or the origins or the creations of mountains. And we've seen that O-R-O-G prefix before when we looked at orographic precipitation, which also relates to topography and mountains. So key to understanding folding is plates colliding with each other. Folding is critical to understanding the Appalachian Mountains, which created it. So understanding it was the two land masses that were colliding were northwest Africa and the southeastern part of the United States were bumping up into each other, and that bumping up to each other created the Appalachian Mountains folding, as you had two land masses colliding. Today we have the Himalayan Mountains. The Himalayan Mountains are examples of folding as the Indian subcontinent comes colliding into the Asian landmass. And this goes back to previously a video lecture 6.3 discussion where we looked at the different plate movements, and there's a reason why I talked about the Appalachian and the Himalayas during that time, because now we can come back and explain and use the key term folding to understand them. Here's a simple illustration from our good friends at Wikipedia of continental and continental collision. Of course, one of the things you'll notice along that collision boundary, you'll get the uplift created from folding and get a very rugged topography there where that collision's occurring. Here's the side view of something I've talked about beforehand regarding the Indian subcontinent coming plowing into the Eurasian landmass. It's coming at a very, very fast pace. And so one thing we'll note is the Himalayan mountains are actually getting taller every year. Slowly they're growing because they're being forced up as that Indian subcontinent comes into and gets buried underneath the Eurasian landmass. So let's watch this happen in motion. As the Indian subcontinent has come over time closer to the Eurasian landmass, and it's physically forced up the area because of folding, producing the tallest mountains in the world today, the Himalayas. And of course, because the Himalayas have such a high elevation, they're going to have that snow-capped features. Of course, as we go further up in the troposphere, temperatures go down. Even further, we note that this is going to create a massive orographic precipitation difference in which on one side we have one of the wettest areas of the world, there in the Ganges River Delta and even further down there in Bangladesh. But then on the other side, in Tibet and even into deeper within China, we have one of the driest areas of the world. And so that rain shadow effect occurs big time here. And it's all due to the Himalayas and that uplift due to folding. Here's a useful image to show the before and after, and shows that reference point, which does not move. It's kind of trying to show that that's the same spot, and how over time it's become uplifted due to that Indian plate going further and further underneath the Eurasian landmass, the Eurasian plate. So thank goodness for this class. Now you know the Himalayan mountains, why they formed, why they look the way they do, why on one side you see the dense vegetation, all that green, on the other side you see one of the driest areas of the world. All of this we can now understand clearly because of G107.